Now we will discuss second problem. So suppose our f of t is given by sine of pi t by L in the range 0 to 2 to L, 0 to L. So we want to find the cosine series. So again as before, to find the cosine series, we assume that our function f of t is extended to minus L to L as an even function, as an even function. Then what we know? We know in this case bn's are 0 for all n. So for every integer, bn is 0. So therefore, our f of t will look like a naught by 2 plus summation n equal to 1 to infinity an cos of n pi t by L. And since bn's are 0, I am not writing them. So to calculate a naught and ax. So first we will calculate a naught. By definition, it is 2 by L integral 0 to L sine of pi t upon L dt, which is 2 by L integral of sine is cos of pi t upon L into 1 upon pi by L, the range 0 to L, and 1 minus sine is because integral of sine x is minus cos x. So we will have 2 by L into L by pi into, I will put 0 first, so it will be 1 minus, if I put t equal to L, I will have cos pi, which is minus 1. So this value is L and L will get cancelled, and I will be remain with 4 upon 5. So my value of A naught is 4 upon 5. Now we'll calculate AN. So to calculate AN, again by formula, by definition, it is 2 upon L integral 0 to L sine of pi t upon L sine of pi t upon L into cos of n pi t upon L dt. I will consider this as 2 pi L higher. So I will try to integrate this value. So, well, instead of doing it by integration by parts, I can think this as sine into cos. So note that sine of a plus b is sine a cos b plus cos a sine b, and cos of, sorry, not cos, I should again go for sine. So again, sine of a minus b is sine a cos b minus cos a sine b. So now if I just add these two, if I just add these two, I will get 2 times of sine a cos b is equal to sine of a plus b plus sine of a minus. Notice that here a is this value, so this value is a, and this value is b. So I will have 2 upon L integral 0 to L sine of a plus b, which is sine of pi t by L plus n pi t by L plus sine a minus b by 2, which is sine pi t by L minus n pi t by L dt. So I can simply rewrite this as integral 0 to L sine of, I will take pi by L common, also T also common, so that I am remaining with n plus 1 plus the next term is pi t by L into n minus 1. And we're integrating this quantity. So to integrate, we will now integrate. So integration of sine is minus, so I will put that minus cos, minus sign outside, so that I will have cos of pi t by L into n plus 1 divided by this, again pi t, so that constant, so pi t by L, pi I am writing again t, so pi by L into n plus 1 plus cos of pi t by L into n minus 1 divided by pi by L n minus 1. And now if we want to put the range, that's 0 to L. So putting the values, this is common. So putting t equal to L, what we will have? We will have cos of n plus 1 pi divided by pi n plus 1 into L minus, putting the value 0, we will have this L value as 1 and again the same denominator, which is pi n plus 1. Now for the next term, here we will have, well, I will take the denominator outside, which is L upon pi n minus 1 into, if I put the value L, it is cos of n minus 1 pi minus 1. So we have minus 2 by L into, note that I can take this L by pi common. So L by pi into, for the first bracket, we are remained with only n plus 1, and this is minus 1 power n plus 1 minus 1. And for the second bracket, we are only remained with 1 upon n minus 1 into minus 1 power n plus 1. Well, it is actually n minus 1, but we can, both are same. Minus 1 power n plus 1 and minus 1 power n minus 1. Both will be same for every n. Minus. So L and L will get cancelled. I will write 2 by L. I will take that minus inside, so that I will have, so reverse this order. So 1 minus minus 1 power n plus 1 divided by n plus 1 plus 1 minus, again this time I will write this as n plus 1 and n minus 1. Well, I can take this common again, 1 minus n plus 1 divided by, we have cancelled out L and we are remained only with pi. So pi n minus 1 plus n plus 1 divided by n square minus 1. So our final answer will be 2 by pi n square minus 1 into this minus 1 and this plus 1 will get cancelled. So we are remaining 2n into 1 minus minus 1 power n plus 1. So note that this value, well, before that I made up a mistake. This is 2 times sine a plus b. So we have to divide it by 2. So whenever we change, instead of 2, everywhere it should be 1. So we have to change every 2 with 1. Again, instead of these 2, and so instead of these 2, we will have 1 and 1 again. So in the final answer, instead of these 2 and these 2 and these 2, everywhere we will have 1 here, 1. So the final answer will look like 2n upon pi n square minus 1 into 1 plus minus 1 power n. So this quantity is 0 if n is odd, and it is 4n upon this 4n upon pi n square minus 1 if n is even. So you can write down the Fourier series. So as you just need to write the even terms. Now for the next example, first. So for the next example, example number 3, we'll have f of x as two values up plus x if my x is between minus half to 0 and half minus x if my x is between plus half to 0. So if you observe that, if you plot the graph of this function, so if you plot the, I'm not good at the drawing. So if you plot the graph of this function, you will see that this function is an even function. This function is an even function in the both sides. Notice that f of x is an even function. Here, 2c is 1. Whole period is 1. So value of c is half. So let f of x equal to a naught by 2 plus summation n equal to 1 by infinity an cos of n pi x by c, but c is half, so this will look like a naught by 2 plus summation n equal to 1 to infinity an cos of 2 n pi x. So since f of x is an even function, since f of x is an even function, we did not care about bns, as bns are 0 for all. So we will calculate n. By definition, it is 2 upon 1 by 2 integral 0 to half minus x dx, which is 4 times integral of this is x by 2 minus x square by 2 in the range 0 to half. If I put the value of half, it is 1 by 4 minus 1 by 8, which is 1 by 8 into 4, it is half. Now for ans, this I'm directly writing 4 times integral 0 to half 1 by 2 minus x cos of 2 n pi x dx, which is 4 into half minus x integral of cos is sine 2 n pi x upon 2 n pi minus, because of this differentiation, it will be plus cos of 2 n pi x divided by minus of 2 n pi whole square in the range 0 to half. Again, we will have that sign advantage and this will be 0. So we will have 4 upon minus 4 pi square n square in bracket. When I put x equal to half, I will have cos of n pi minus 1. So this will be 1 upon n square pi square into 1 minus minus 1 power n. So this quantity is actually, when n is odd, it is 2 upon n square pi square if n is odd, and 0 if n is even. We will write the Fourier series. Fourier series will be f of x equal to a naught by 2, which is 1 upon 4, plus I will take 2 upon pi square common, and I will have summation n equal to 1 to infinity. I am writing only the odd terms cos of, well, that it will be difficult to write the term this way, but you can just simply write first 3 terms and we are fine with that. So don't need to write this generalized form if you don't understand. It's fine if you go for simple or 3-term extension. So just write the first 3 terms and dot dot dot. Now for the last problem, we'll have f of x as a split function. So 2 in minus 2 to x to 0, and instead of 0, we'll complicate things a little bit by doing it as x. 0 x in. So notice that f of x is neither even nor odd. So we have to go for our usual thing. Usual things mean whole series. A naught by 2 plus summation n equal to 1 to infinity. Then an cos of n pi x by 2 because here c is 2 plus summation n equal to 1 to infinity dn sine n pi x by 2. Why c is 2? Because for 2c the whole range is 4 minus 2 to 2. So c is 2. So first let's calculate a. A naught is 1 upon 2 integral minus 2 to 2. Notice that this time I am not multiplying by 2 and taking the half range because we are considering a general problem where we don't have even and odd advantages. So it's half. I need to split the integral into two parts. First is 2 dx and the second is x dx. So this is half 2x in the range minus 2 to 0 plus x square by 2 in the range 0 to 2. So if I put this value, it will be 4 plus 2, which is 3. Now, to calculate ans, to calculate ans, we have 1 upon 2 integral minus 2 to 2 f of x cos of nx pi upon 2 dx, which is 1 upon 2 integral minus 2 to 0, or f of x here is 2 cos of n pi x upon 2 dx plus integral 0 to 2. Here our f of x is x cos of n pi x upon 2 dx. So this will be 1 upon 2 times integral of this value is sine n pi x upon 2 divided by pi n by 2 plus, well, for the second quantity it is x into sine n pi x by 2 divided by n pi by 2 minus cos of n pi x by 2 divided by minus of n pi by 2 whole square. This is in the range of minus 2 to 0, and these quantities are in the range of duality in the range 0 to 2, 0 to 2. Notice that our half range is 2. So these are multiple of, so these sign terms will get cancelled. So we need to evaluate only the first term. So this minus and this minus will become plus. So we will have half into 4 upon n square pi square into, when I put the value 2, we will have cos n pi minus 1, which is 2 upon n square pi square into minus 1 power n minus 1. So this quantity is even or odd, where if 0, if n is even, n is odd, n is odd, and 4 minus 4 upon pi square n square if L is T or other way around. Yeah, it's other way. It's 0 if n is T1 and minus 4 upon pi square n square if n is odd. Now the Dn. Dn is by definition 1 upon 2 integral minus 2 to 2 f of x sine of n pi x by 2 dx, which is 1 upon 2, splitting the integral into the two parts of the two function, which is sine n pi x by 2 plus integral 0 to 2 x sine n pi x by the whole dx. I should write this dx and here dx, which is 1 upon 2 times cos of n pi x by 2 divided by minus of n pi by 2 plus integral of these quantities x into cos of n pi x by 2 divided by minus n pi by 2 minus, well, I am keeping this minus because differentiation is positive and I will take one negative in the denominator and evaluate it later. So that's sine n pi x by 2 whole divided by minus of n pi by 2 whole square. So first quantity is evaluated in the range minus 2 to 0. And this quantity is 0 to 2. And I think this quantity 0 to 2. So again, sine term will vanish. There is nothing to calculate. So we are remained with half of 2 into 2 upon minus n pi. Well, I will just evaluate in the reverse way so that we will get rid of this minus. So if I put n equal to minus 2 first, this will be minus pi x minus n pi. So minus n pi is actually cos n pi, which is minus 1 power n, and putting the value 0, I will get. Then in the next term, when I put the value 2, I will get 2 times 2 upon n pi, and putting the value 2 cos n, which is minus 1 power n, and putting the value 0 because of this x, the term will vanish. Notice that this term with minus 1 power n, and this term will get cancelled and with the term with minus 1 will get. So that's why we will have this 2 will get cancelled with this 2. So we will have minus 2 upon n pi. So write down the Fourier series of x a0 by 2, which is 3 by 2 minus 4 upon pi square. I can take common. I'll write down the first few terms. Just check it out and evaluate a few values, and you can find out. Well, it's not 12, it should be 1 square, and then 3 square cos of 3 pi x by 2 plus dot dot dot. And after that, some terms containing, so some terms of sine terms. Some sine terms are, again, those terms are negative with a constant multiple of 2 upon pi. I will have 1 upon 1 sine pi x by 2 plus 1 upon 2 sine 2 pi x upon 2 plus dot dot dot. So this is our required Fourier series. Thank you for your attention.